Hello, everyone, and thank you for joining me. My name is CTrebil, and my presentation focuses on the transformative potential of generative AI in cancer research. While this technology offers groundbreaking advancements, it also introduces complex ethical, technical, and cognitive challenges that demand our attention. Over the next few minutes, we'll explore both the opportunities and the responsibilities that come with integrating generative AI into such a critical field. To begin, I'll provide a roadmap for the discussion. First, we'll explore the role of generative AI in revolutionizing cancer research, highlighting its applications and benefits. Next, we'll examine its impact on critical thinking and originality among researchers, followed by the ethical implications of its use. We'll then wrap up with key reactions and a forward looking conclusion. With that, let's get started by looking at how generative AI is reshaping the landscape of cancer research. What happens when cancer researchers increasingly rely on generative AI for innovation and analysis? That is the research question that was inspired by connecting the ideas of Nicholas Carr and Hans Jonas and then asking the next question. Carr's work explores how technology affects cognitive engagement and critical thinking with technologies like the internet, raising questions about how over-reliance on tools like generative AI impact these same elements. Jonas's work can be used to extend this discussion by examining the moral responsibility to consider the long-term societal impacts of technology, specifically in this case, generative AI. Together, these perspectives framed the research question of how generative AI influences not just cancer research outcomes, but also the researchers themselves. Framing the research with those perspectives is what enables the examination of the transformative role of generative AI within the field of oncology and cancer research specifically. This is also a timely issue, as 10% of abstracts published in the PubMed database contain signs of being written by generative AI tools like ChatGPT. So, as AI tools increasingly reshape oncology, they are also quickly raising critical questions about ethics, innovation, and responsibility in research. So, as we move into discussing the role that generative AI plays in cancer research, we can very easily see that AI is already revolutionizing cancer research and the overall field by enabling faster and more accurate analysis of very complex data sets. Current applications of AI within oncology and research support tasks like diagnostic imaging, analysis, biomarker discovery, novel drug development, and personalized treatments that further improve patient care and help the pathologists and clinicians improve diagnostic accuracy. For example, we can see in Figure 1 how an AI tool was used in research at New York University School of Medicine to identify the two different types of cancer cells shown on the right in blue and red that are present in a patient's lung with the normal lung tissue shown in gray. This sort of identification is something that experienced pathologists often struggle to complete without additional testing and procedures that overall just further places the burden on the patient and slows down the process. However, in this case, the AI tool was found to be 97% accurate in distinguishing between these two types of lung cancer, and it was 86% accurate in identifying abnormal versions of these cancers as well. Such diagnostic tools allow patients to receive care quicker while also receiving targeted treatments for the type of cancer that they actually have. Possibly even more interesting in this case is that the studies surrounding this AI tool found that in 83% of cases where a human pathologist misdiagnosed the type of cancer, the AI tool had actually made the correct diagnosis, which shows it is very much a viable tool for second opinions. However, even with all of the clear promise that AI brings to oncology and the field of research, there are several challenges that were present throughout the literature reviewed in this research. First and foremost of these challenges is that over-reliance on AI risks reducing critical thinking and creativity among researchers. Additionally, biases in the training data and the opaque nature of AI-generated outputs can limit transparency and trust. And finally, privacy concerns also arise when handling the kind of sensitive patient data often required for effective cancer research. So while generative AI offers efficiency and the ability for researchers to accelerate timelines, its automation of complex tasks does risk diminishing researchers' critical engagement. What the research found through the literature was that the over-reliance on AI tools can very clearly reduce creativity and analytical depth, making it crucial for researchers to remain actively involved in interpreting the results. Looking at the chart, you'll see the key differences between traditional research methods and AI-driven approaches. Traditional methods rely heavily on human insight, deep engagement with the data, and an iterative problem-solving process, which fosters creativity and critical thinking. In contrast, AI-driven methods excel in speed and efficiency, but they risk encouraging superficial engagement and over-reliance on automated outputs. While AI tools can enhance certain aspects of research, they should complement, not replace, the intellectual rigor and innovation that define meaningful scientific discovery. One key issue in the decline in deep engagement is the tendency for researchers to skim through AI-generated outputs without fully engaging with the underlying data. The literature suggests that this lack of deep interaction could lead to a surface-level understanding of critical findings, further compounding the risks of misinterpretation over time. For instance, reliance on large language models can result in researchers accepting predefined patterns without ever questioning their limitations. Similarly, over-reliance on AI tools can stifle creativity among researchers, and automating hypothesis development or treatment modeling may prevent researchers from creating novel approaches to complex problems. The black box nature of AI, where outputs are often produced without any sort of transparency, further limits researchers' ability to explore any alternative perspective and to really push the boundaries and think outside the box. So as we look at the impacts of generative AI on critical thinking and originality, it's important to also consider what might happen in the long term if over-reliance on AI tools continues. As researchers become more dependent on AI for tasks like hypothesis generation and data analysis, we could see a decline in their ability to engage deeply with complex problems. This reliance may lead to less rigorous evaluations of findings, with AI outputs becoming accepted without any sort of truly sufficient scrutiny. Over time, this could erode the quality of research and weaken the field's capacity to uncover transformative insights. AI-driven models, while efficient, often prioritize existing patterns and data. This limits the scope for unconventional or breakthrough ideas, which are absolutely critical in advancing complex fields like oncology. The field risks becoming locked into a sort of cycle of predictable discoveries, where innovation is ultimately stifled by the very tools that are meant to accelerate progress. Perhaps the most pressing concern is how future generations of researchers will adapt to these technologies. If reliance on AI becomes too ingrained, these researchers may lack the foundational skills and critical thinking abilities needed to independently advance the field and come up with further innovations. This could lead to a gradual loss of expertise that continues to be magnified with each generation and lead to a state where innovation and depth are replaced by convenience and a superficial understanding of the information. These potential long-term consequences further underscore the importance of balancing AI capabilities with human expertise, a theme that ties into the broader ethical implications and strategies for responsible innovation discussed in the next slide. So as we've seen how generative AI brings transformative opportunities to cancer research, its integration also poses significant ethical challenges. These issues extend far beyond immediate applications and will require long-term ethical frameworks to guide responsible innovation. In particular, research integrity faces considerable challenges from the black box nature of AI. Large language models also show a high degree of variability in performance and can produce authoritative sounding yet factually incorrect content, which could significantly impact ongoing and future oncology research. Also, bias in AI training data further complicates the reliability of these findings, as researchers may be increasingly working with flawed data sets simply by integrating AI tools into the research process. Patient data privacy is also a critical concern in cancer research due to the sensitive information like genetic profiles often being used for analysis. Additionally, demographic imbalances in datasets, such as the overrepresentation of individuals of European ancestry, could create inequities in AI-generated recommendations. And these concerns reinforce the need for active human engagement in developing inclusive and representative training data to train AI models. While the research was not scoped to fully explore potential solutions offered by modern theoretical frameworks, it is worth noting that there were signals in the literature that aligned with continuing to build on Hans Jonas's concept of long-range responsibility, which emphasizes the need to consider the well-being of future generations. For example, a possible modern framework could look something like the Responsible Innovation Framework, which provides a structured approach to ensure generative AI serves societal values while maintaining accountability and equity. Overall, active involvement from researchers is the key, and that is what will be essential to ensure that AI tools remain transparent, equitable, and aligned with ethical standards, paving the way for responsible innovation in cancer research. Reflecting on the research, it's clear that generative AI represents a series of pros and cons. On one hand, its capabilities in data analysis and personalized treatment planning hold immense promise, offering opportunities to revolutionize oncology. On the other hand, unresolved ethical concerns present significant challenges. Generative AI has already enabled genuine breakthroughs in analyzing complex data and tailoring treatments to individual patients. And these advancements could further enable researchers to accelerate progress and improve patient outcomes and advance scientific discovery. However, there are serious concerns about research integrity and the potential for generative AI to undermine critical thinking and creativity. As researchers increasingly rely on these tools, it's essential to consider how they may affect the depth of intellectual engagement over time. Looking ahead, future studies should focus on the long-term impacts of generative AI on research practices, particularly its influence on deep engagement and innovative thinking. There's also a pressing need for research aimed at developing transparent and unbiased AI models to ensure equitable outcomes. Addressing these areas will be key to ethically integrating generative AI into cancer research in the future, balancing innovation with responsibility, and maintaining patient well-being. Based on the research for this project, it's clear that the field of cancer research is at a pivotal juncture. While AI offers unparalleled opportunities to revolutionize research, the literature makes it clear that any potential benefits also necessitate a growing need to address critical challenges and ensure that the technological advancements align with ethical and societal values. The most important insight from this research is the necessity of foundational knowledge for researchers. Cancer researchers must have a strong grasp of core oncology principles before integrating AI tools into the research process. This ensures that researchers can critically evaluate AI outputs, contextualize findings, and address potential inaccuracies or biases. Without such expertise, there's a clear risk of over-reliance on AI, leading to surface-level analysis and flawed conclusions. One of the most pressing challenges found in the research lies in maintaining the iterative and exploratory processes that drive innovation. As generative AI automates complex tasks, it also creates a clear risk of diminishing researchers' active engagement. To foster creativity and innovation, it will be increasingly important for leaders in the field to promote active human involvement alongside AI capabilities. So in conclusion, thoughtful leadership and ethical decision-making are absolutely essential for advancing oncology responsibly in the age of generative AI. By striking that correct balance between innovation and responsibility, researchers in the field can harness the full potential of generative AI to benefit both current and future generations. Thank you for your time and attention. Generative AI holds immense promise for transforming cancer research, but its success depends on how responsibly and thoughtfully the subject matter experts and leaders in the field implement it. Through a conscious effort to uphold human engagement and oversight, along with balancing innovation with ethics, equity, researchers can ensure that advancements lead to meaningful and lasting progress for all stakeholders. With that, I look forward to everyone's feedback. Thank you.